Hello everybody, welcome back to another edition of the EcoStruxure Machine Expert Training. I'm your host, Leandro Humada, and in this video we're going to see how we can give an address to the variables that we are going to define on the GBLs. So let's go to the presentation. So in order to start with this, in order to understand how we are going to give an address to the variables, it's important to know the size in the memory of the PLC for each of the variables types that we have. So in the next slide, we can see the different type of variables that we can find in the software, okay, and the size of each variable that we have. Probably here is one of my biggest confusion here. Probably I'm wrong, but I believe this I found it on the data types on the help. Is the size of each of these variables. Okay, you can see here, for example, the Boolean, which is just a variable that has two states. Okay, it looks like the size is 8 bits. Okay, even if you have only two variables that go from 0 to 1, true and false. And then we have, for example, here, let's just go to the full screen. Okay, we have the bytes. Okay, the size is 8 bits. Okay, then we have the integer, and we have single integer, then double integer, and long integer. And here you can see the size from 8 bits, 16 bits, 32 bits, and 64 bits. The same with the unsigned. Then we have the word, the real, then we have the time, okay, operation, and the strings. Okay, so here there's some more information about this stuff that I mentioned. Okay, bool type variables can have values true and false. This is what I mentioned before, and the 8 bits of memory space are reserved. So in this case, even if we know that the Boolean, okay, Boolean variable that has the value true and false, it requires the 8 bits. If I'm not wrong, I took it from the online help. So we'll continue with this. Now we know the different sizes and different types of variable that we have on the software of Machine Expert. Now, in order to identify or how we're going to identify in the code the variables, okay, we need to think on the way that we're going to name those variables first. Okay, it's not just enough to give it just some random name for the variables. It's not better to have an order on how we're going to name the symbol for this variable, so we can easily identify when we are reading the code, and somebody else can read it also. Okay, so we have like this Hungarian rule in order to have a global understanding of when we program and declare the variables. So if we go to the full screen again, you can see that this is just it's not mandatory, okay, but it's just a guidance. So the idea here is to have, based on this, if this input and output, okay, the variable scope, which is optional. Then if it's a pointer, okay, you have the P over there. Then if it's the field, optional, okay, if it comes from left side or not, and then the data type, and then the variable name. Okay, so later we're gonna see that probably you can have this is not mandatory, but it's just a guidance. And what I usually do is to, for example, start with the variable type, and then with some random description of the structure of the element, and then the action. So you're gonna get used to try to have an order and simple ways in order to name the variables. Okay, so in order to address the variable, we need to first define the variable name, which is this part, and then we need to define the type. Okay, probably if we know the type, we should be able to predefine and have a better name for the variable. Okay, once we all this, we should be able to access and try to define the variable address. But first, if we continue with this kind of guidance, okay, we can use a prefix for each variable. So if we take into account the previous page, this one, okay, for the all different variables types that we have, okay, and we complement this information with this Hungarian notation, okay, we have this prefix, okay, that we can add. For example, if it's Boolean, we use the X as a prefix, byte to be for Bravo, okay, and then here you can get the idea how it is, and then the name of the variable. So since it's just a guidance, okay, and it's good, so when you are reading the code, you can understand, okay, this variable is this type, and this variable does this, okay. So just to have an idea and to be easy for everyone to read the code. Okay, so if we continue with this, now that we have all this information, it's time to declare the address for these variables on the software. So on the GBLs, we have the textual and the tabular view, okay. Probably the easiest way to create the variables is going to be the tabular, but once you have more experience, you can go to the textual, so you can easily copy and paste and modify much faster. So let's continue with this part. So here you can see how is the syntax to create a variable, okay. You just need to start with the variable that you want, the 2 points, I believe it's colon, and then the type that you want based on what we've seen here, the data type. Then we just fill in with the semicolon, okay. This is an example in all this kind of variable that we can have. Then if we switch, we can see how is the description. And in here, the tabular is very simple, okay. You just add a new one, define the name, and then the data type, and if you want, just a comment. So as you can see, it's very simple. So if we continue with this idea, okay, so let's open the application. So I have already made this. So if I have this GBL, okay, we have an empty GBL with just one variable. So you can easily start writing your code. For example, W motor, W for word, motor underscore run. Okay, you can define like this. So when you see this, you can say, okay, it's a word type, is regarding to a motor. You can give for the description the motor name, and then the command is going to be run. So something similar to that. Or you can use, for example, if you need to enable something, is a Boolean, hex cmd for command, then underscore motor run, or put together everything what you want. So just to give you an idea how to define the variables and how to name it. Okay, just try to use like a guidance and try to follow that when you're working in the code to easily understand that. So this is the textual part. Then you can go to the tabular using these icons over here. You can see you have the tabular, and you have the textual, and you have the tabular. So if you select the tabular, it will change to the other one, as you can see over here. Okay, and pay attention to something. If you replicate the names or you make a mistake here, okay, you will probably receive an error message on the tabular. Okay, so you will need to pay attention on this, and if you have this kind of message, you just need to go to the textual and find the modification. So if I delete this, select tabular, there you have the variable once again. So add a new variable in this one, insert the name that you want, cmd motor stop. Okay, you can see you can easily change this, and you have this help, the wizard assistant, input assistant, and here you can define the type in case you don't know how to name it or how is the data type name. The tabular view is very easy to define the variable that you want. Okay, so if you're not comfortable with the textual, you can go to the tabular and it's gonna be fine. Real, if it is real, probably you can change this part. Real, stop, probably the action is not gonna be stop, but you can have it, yes, In my case, I'm going to refactoring when you need to change something, okay, in the tabular view. That's important. When you make a change on the tabular view on the some of the elements that you have, the software allows you to make a refactoring. So you can, the software can show you, okay, you have been using this variable over here, let's make the change in the complete software. So you proceed, okay, and it will change over here. And if you want to go back to the textual, just select the textual view. So easy for the spot. So before addressing, it's important to know how you need to define a variable, okay, and then the data type of this kind of variable that we have. So if we go to the presentation once again, okay, this is an example of the different configuration for the different data types, as you can see, okay. The structure is the same, colon, data type, semicolon, okay. The only difference is the strings, W string. You can see here the string only take only 1 byte per character and the other one 2, okay. Here is the view. This is very straightforward. So now on the PLC, okay, how the memory is divided by bytes, okay. So that is something that you need to be careful when you're trying to read, for example, from other device like an HMI, and you're trying to read a specific address on the PLC, okay, because it's divided by bytes. So in the other side, you're trying to access by word, okay, and you want to see now the confusion that probably may have trying to do this. So if this is the area of the PLC, okay, let me just make this pan. This is the area of the PLC, okay, and you define all your variables over here, okay. You can see if you need to define a word type, if you go back over here on the size, okay, so this one, if you define a word, the size is going to be 16 bits. So this one is going to be 2 bytes, okay. So if we go back over here, you can see the first 2 bytes belong to the percentage NW0, okay. So these 2 belong to this, and this one to this 2, okay. So you can see how it's divided over here. So just to have an idea how it's related the sizes of the variable that we've seen before into the memory of the PLC. So if you have a double word, okay, the double word has 32 bits that belongs to 4 bytes, okay. So you can see over here the percentage MD for double have 1, 2, 3, sorry for the notation, 4 bytes, and the MD1, which is the next double word, okay, have another 4, 1, 2, 3, and 4. So here you can get the idea how it's divided. 1, 2, 1, 2, and if you go to the long word, okay, for example, L real, okay, variable, it has 64, and 64 will be 8. So you have for this one 1, 2, 3, 4, 5, 6, 7, 8 bytes. And you can see how is all this together over here. So in this way you can get an idea how it's organized the variables, okay. So the software allows us to freely assign the variables, okay. It's not mandatory to assign, okay. We're going to see another method in order to address the variable, but what I want to show you here is that we have the possibility to assign the variables address that we want. So what we need to be very careful here is not to overlap the addresses, okay, between the different variables that we want to have. So we continue with this. Okay, let me just delete. Perfect. So another thing that we need to check is in the booleans. Okay, the booleans go from is divided by byte. So in the byte that we have from the bit 0 to the bit 1 to 8, okay, there's going to be the 0 to 7, okay, and the next byte, okay, is not divided by word, because sometimes the words, okay, the percentage NW goes to 0 to 7, 8, okay, to 15, okay. This is like the some, we're gonna see this when we're trying to communicate with the HMI. So in the PLC, it's not divided from 0 to 15, it's divided in 2, because the word that we have, it has 2 bytes, and there are 2 independent bytes that we need to read over here. Okay, it's just to have an idea what we're gonna do later. Okay, so let's delete all this part just to have an idea what is this. So if you pay attention over here, there is like a sequence on how to know which should be the word or double word of the byte in case we are trying to access to some information. You can see over here that in order, if you are working a byte, if you're going to know, okay, which should be the word or double word, we just need to divide by 2. Okay, so from here to here, divided by 2. From here to here, divided by 4. Okay, divided by 4, and here divided by 8, just to have an idea. So if you want to know, okay, which is this one, we just divided by 8, it's gonna be 0 dot something on something, then you can know, okay, it belongs to the LM0. And the other way, if we, for example, working with the percentage NW2, and we need to know which are the bytes, we just need to multiply for 2, okay, just to know where the variables is located. But we're gonna copy this part. Great, so if we continue with the presentation, let me just check this, perfect. So this is what I meant. So if you have a percentage bit, this is just an example, just to have an idea how to check if they are overwriting the variables that we have defined, okay? What I usually do is to separate if I need, okay? It's not mandatory to do this, because if you are working with our HMIs, you can use a symbol configuration to easily share the variables, and you don't need to worry about this, okay? And if you need, for example, to share variables to an SCADA, you can use OPC UA, for example, for our controllers, and there is nothing else to do. But I'm going to explain you how the memory is located, how you locate the variables in a specific memory, so you can access from another system, okay? But this is not mandatory, because the EcoStruxure Machine Expert works with symbolics, with symbols. So just to have an idea how this works. So let's continue. So this is just a rough idea how to calculate or how to see which are the variables that we have. So if we want to define a bit, just laser band. So if we want to define a bit variable in our system, we just need to use percentage %mx, and then the byte. This is going to be the byte, okay, dot the bit, okay, the bit that we have that goes from 0 to 7. Okay, this is how you can define the bit. Now, if I want to know which is the byte, okay, imagine that you want to just check for the notation and everything, should just need to go to here in byte, okay, just need to use the byte, and that's all. So this is how you can name it. Now, if you want to check which is the in word instead of bytes, okay, you just need to use the bit, okay, the byte and the bit, then just divided by 2, okay, the value that you have over here, and you're gonna get the result of the word. Because remember, if we go over here, we just need to divide by 2 to get the word. And we know that this part over here, all this part is the byte, and this one are the bits, okay? Just to give you an idea. So this is just to let you know if the bit is, if the bit is over, the byte is going to be byte over here. If the byte is even or odd, okay? So this is not bit, I need to change it. It's going to be byte, okay? The byte, because we are in the byte. So we just need to use the integer part, okay? So we just divided by 2, okay? And we have the possibility to use the percentage NW over here, okay? And then I'm going to explain to you how to find inside this word the exact bit, okay? This is just to have an idea that the addresses are not overwriting, okay? This is not how you can access directly from outside, okay? Just to give you an idea where the variables are located so you can know if they are overlapping. Just that, okay? Once you get familiar with this, it's going to be easy. So here in the byte, if you're using byte that you want to use the word, is similar to the process that we had before. And here, okay, similar to this, we just need to divide it by 2. Okay, you can find that the byte that you're going to use, the odd, is going to be inside this part, okay? Then we can see in which area, okay? Now, if it's a double word and you want to know which is the word, okay, we just need to multiply by 2, which is this part. For example, I in this, just multiply by 2, and I get the percentage NW, okay? So this is just to identify that we are not overwriting information of the value that we have received. This is not how we can access externally, okay? Externally, we're gonna cover that. So this is finished, this part. So let's see now how it's gonna be in our case. So in order to define now a variable, okay, with an address, we have seen before that is very straightforward. We just define over here the icon, the name of the variable, the column, the data type, and then semicolon. This is the structure that you need to use in order to create a variable, to define it. Just delete this. We continue the presentation. Now we have a new syntax. To the one that we had before, we need to add this, the @ The @ is mandatory in order so we can assign an address, and this is going to be the position, okay? And the position will be related to where we want to locate the variable types, okay? Here you have an example for all the different data types that we have, okay? So you can have an idea how you can define, for example, a word, okay? You just need to use the MW. L word, you have the percentage ML. If you want to define, for example, this one over here, there are percentage ML, real, percentage MD. So this one is just to have variable types in the system, okay? And if you go to the textual, from the tabular, you can see in a probably simple way how it's organized, as you can see over here. You can see here the address, and you have a specific column for the address, so you can easily see that, okay? But let me just go back to the software here, okay? So here you can define a variable at percentage MD 20, okay? You can see now it's validated, otherwise it's going to be wrong, okay? You can see that the precompile has given you some indications over there, MD12. So if we go to the tabular, you can see that you have some variables. Here should be MX 2.4, whatever, okay, no problem. Now, if I delete this, you can see now that the variable has deleted that part. If I go over here, tabular, there we go. So this is just an example how you can address the variables. Okay, in the presentation part, you can see the different types or different ways to locate the variables. Okay, as you can see, very straightforward. You have all the indication in case you have any problem, but it's in there. It's in there. So let's continue with the presentation. Okay, so now that we have this is gonna be probably the thing that we need to be careful when we want to, for example, read from an HMI from our PLC the information that is located in a Boolean variable. Okay, because it's located in the PLC is going to be located in a byte. Okay, and the HMI is going to try to read a word. So in there, we need to be careful in which position on the byte inside the word is located. Okay, that is what we want to show you. So if we go over here, okay, the HMI is trying to read from the bit 0 to 15, which is a word, which is correct. And in the PLC, the word, any word that we're trying to read, we'll start with the byte, okay, with 2 bytes, because it's trying to use a word, okay, percentage MW. This one is going to be percentage MB. I need to work on the drawing, percentage MB. Okay, so this is what I meant. So, for example, in this case, okay, I have this variable percentage mx205.4. This part, okay, is the byte. Okay, this part is the byte. So in order to get to know the word, we just need to divide the byte by 2, which is the thing that I have done over here. You can find it over here. Okay, so this is going to be the word. Okay, now in the PLC, okay, on the HMI, imagine this case, I need to read the percentage from the PLC, okay, percentage MW 102. Okay, on the HMI, in the HMI, you need to read this one. On the PLC, it's gonna be this one, the percentage. It's gonna be 205. Okay, and the bit 4. This one is gonna be the percentage mx. Sorry for the drawing. 205.4. So here, I believe you're getting the idea what we need to do. It's a little bit different here, how you need to address, because now the bit on the HMI side is not going to be the bit 4, it's going to be another one, okay, because we are reading the same area, but the location is going to be a little bit different. Okay, so if we go here to this part of the presentation, okay, you can see that the bit 4, okay, that we have over here, is going to be the bit 12. Okay, so this is because this one is an odd number. Okay, if we know that we're going to be the odd number, it's going to be in this side on the byte. Okay, so in order to get this value, the 12, the simple would be, okay, we know that the first byte is going to be 8. We just need to add the 4th position. Okay, 8 plus 4 position is going to be 12. It's going to be located in here. Okay, just to have a rough idea how you can access. So on the other side, on the HMI, in order to access to this part, we depend on the characteristic, how to address and the syntax on the HMI, but probably you need to use percentage x 12. Okay, we're gonna see that on the HMI part. So this is how you can access to the variables. If you want to use, for example, a third-party HMI, you need the registers. Okay, this is one way to do it. We're gonna see that later using the relocation table next. Okay, so let's continue with this part. Let me just double check something here. So what I'm going to do now is to open the Operator Terminal Expert, okay, which is one of the software for HMIs. What I'm going to do also is to download this application on the PLC, okay. We're gonna cover that later, how to download the application to the controller, but we're gonna cover that later. I just want to focus on how to address the variables. Okay, so let's try to access to this variable, the percentage MX 50.0. Okay, so here on the HMI we just need to add a driver. Okay, I'm going to use the Schneider Electric Modbus TCP master. Okay, if we go over here, you have another driver which is Machine Expert that allowed us to easily exchange information, but I believe I already made another video regarding this part. Okay, now the idea is to focus on the addressing of the variables. So Modbus TCP, okay. I'm going to use, for example, PLC underscore M251 is in my case, and the IP address of this one is going to be like this. If I'm not wrong, yes. Syntax. Okay, yes. Now, on the variables in this case, I'm going to add a Boolean variable. Okay, that's going to be the X variable, just the name. The source is going to be the M251, and here the device address, you can see that I have MI, and I need to use this one, percentage MIW. So the MWBU in this case, if we follow this, okay, let me just erase everything. Oops, just hold on. So if we start with this now, okay, I have in my project this variable. If I go back here, the percentage MX 50. So if we go over here, okay, percentage MX 50 dot 0. We need to divide this part by 2. Okay, so it's going to be 25. So the memory address, this is going to be the percentage MW 25. So we can start writing that on the other side. Device address, percentage MW 25. Okay, 25. So that is going to be even, so it will start from here. So the first bit is going to be the bit 0 over here. So if here bit 0 is going to access to that value. So if we go to the screen here, and if I toggle switch, this is just an example, current value, variable, okay. Let me just simulate the HMI so we can have the communications with the other PLC. Just open the PLC. So if I know wrong, okay, now that I have this, should be able to answer this one. Okay, so it's very straightforward in here. So let's try another test and play with the bits inside this one. No, let's play with a word. This one, percentage NW 9. So no, I didn't want to do that. So let's try to access to the percentage NW 9 bits. Okay, so percentage NW 9. Okay, come on, laptop. So percentage NW9, W variable, okay, it's gonna be external. Percentage NW variable, I don't remember the name. I have been given the address, gonna be number 9. Okay, perfect. It's gonna be 9. In this case, we are not trying to access, or it's not defined, the variable is not defined as a bit, so I can directly access to the bit inside this word directly without any problem. So if we continue, let's try X variable from the word. It's gonna be Boolean percentage NW9, and the view bit 00, copy paste bit 7, just to have an idea what I'm going to do here. Bit 15. Here, if we modify this to the bit 7, this one's going to be the bit 8, and this one's going to be the 815. Now, if we go over here, I'm going to add 4 of these. Let's change this first. Variables. This is just to show you how you can access to the information. So it's gonna be the 7, 8, and 15. Okay, and here going to add a numeric one to show the word. Okay, I believe 5 is gonna be enough, but just in case, let's add more. I haven't thinking that too much fast. Here we're going to show the binary, and if it's binary format, this will be integer digits. I believe this is gonna be fine. Okay, let's give it a try now. So if we simulate the HMI once again and connect to the controller on this side, okay, which is the variable, this one. You can see it's the number 1. This is the bit 7. Okay, how you access to this? Let's try to, and the value is 192. We change this to display mode binary, which we're able to see the same information. Okay, so this is how you can easily access to the information of the controller. Okay, just double check something here. Okay, so in this test that we have done today is how you can easily address the variables. As you can see over here, the different ways to address the variables that we have on the EcoStruxure Machine Expert. You can see that you need to be very careful when we define the address for the variables. We need to check that there are no overlap. In case you want to overlap, that's up to you, but you will need to be very careful to overlap the address of the variables. Okay, it's not like the M251 that you have like a different area for the booleans, and you have a different area for the words, double words all together. Okay, this is different, it works differently, so you will need to pay attention on that. So today I believe we already covered how to define the variables on the Machine Expert, different type, and how you can communicate with a HMI, and where you need to be careful when you have bits and you want to share those bits to a third-party device. Okay, so thank you very much for watching this video, and I see you on the next one.